In this video, I'm going to explain how we can use a formula for finding the number of subsets rather than always just listing them out and then counting. It can be more efficient to use the formula, and then we're going to use the formula to do two examples. So before I just write down the formula or formulas, because we have two of them here, I just want to go through a couple of examples that I have shown here. Let's consider the set 1, 2. So I'm looking here on the left-hand side. And if we have this set, if I list out the subset, so I just use that terminology or the symbol here, which is the U with the sideways U with the line underneath it. If I were to list out all the subsets, I'd have the empty set, because that's always included, set with 1, with 2, and then the set itself, because remember, a set can always be a subset of itself. So I have 4 altogether. So if I have a set, in this case with 2 elements, there are 4 subsets. And then if I list out the proper subsets, it's basically a repeat of what I have here on the left, except I didn't include the set itself because by definition a set cannot be a proper subset of itself. So there's 3 here. There's always going to be one less proper subset than subset. So I have 4 subsets and 3 proper subsets. And then we can look at this example, set ABC. So this is a set with 3 elements. And let's look at the total here of subsets. So if I list all of those subsets out, I get 8 of them. And if I list all the proper subsets out, I get 7. So still I get 1 less than the number of subsets. So if we want to find a formula, what we can do is we can look at the number of elements. So if we look at the number 2 and ask ourselves, what could we do to 2 to get 4? Well, we could do a lot of things. We could square 2 to get 4. We could multiply 2 by 2. We could add 2 to get 4. Well, we're trying to find a rule that will work for every scenario. So then we have to come over here and say, okay, well, let's look at multiplying. If I take 3 and I multiply it by 2, well, I don't get 8, so that doesn't work. If I take 3 and I add 2, well, that doesn't give me 8 either, so that doesn't work. Maybe I could try something with an exponent, and that's what the formula actually has us do. So the formula for finding the number of subsets with n elements is 2 to the n power. And if you look at these examples, you can see how this works. So if in this case on the left, I have 2 elements, so n is 2. So the number of subsets is 2 to the nth power, or 2 squared, and I end up getting 4. Over here on the right, I have 3 elements, so n equals 3. So if I do 2 to the 3rd power, which is 2 times 2 times 2, I end up getting 8. And so this will work for any set. So let's say the set has 15 elements. You wouldn't want to sit and list out all those subsets. It would take a really long time. So I could just you'd use this formula to figure out the total. And then the formula for the number of proper subsets is really similar. It's just 2 to the n, and then you're going to take away 1, because like we saw up here, there's always one less proper subset than subset. So let's go ahead and do a couple of examples where we can use these formulas. So in example 5, it says find the number of subsets and proper subsets of the set with 1, 3, 5, 7, 9, 11, and 13. So we have 7 elements. So n equals 7. You can imagine if you were going to sit and list out all the subsets, it would take a long time. I mean, you could have 1, you could have 3, you could have 1, 3, 7. I mean, you could have any combination of these numbers, including the empty set. You would be here a long time. So we're not going to do it that way. What we're going to do is we're going to use the formula. So the number of subsets is equal to 2 to the nth power. So we're just going to take 2 to the 7th power, and that'll give us the total number of subsets. So I'm just going to type in 2 raised to the 7th power, and I get 128. So there are 128 subsets. And then to find the number of proper subsets, it's just going to be 1 less than that. So 128 minus 1, which is 127. Okay, so let's look at example 6. This one's a little bit different. It's more of a story problem. We have to do a little bit more thinking than example 5. So Kara has a pile of 13 books on her desk. She's packing for a trip. She will bring some or all of these books. How many possibilities are there for her choice of books to bring on the trip? Now, This one's a little hard to imagine, so I'm going to actually list out 13 books, and I'm going to name them just using a letter. So I'll call the first book Book A, Book B, C, D, E, F, and I'm going to count so there's 13. So we've got 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we got one more. Okay, so those are my 13 books. And if we think about how she could, how many possibilities there would be for her to bring these books on the trip, you could imagine, well, she could bring book A. She could bring book A and B. She could bring book A, D, and F. She could bring book B, H, and I. There are a lot of different possibilities. To list these out would take a really long time. So let's consider all of the possibilities and then how we could calculate the number of subsets and use that to help us. And so it says right here that she will bring some or all. So what about none? Is that a possibility? Does it say anything about that? It doesn't. It says she's going to bring some or all. So I would say this is not a possibility. So she's not planning on bringing none, or on not bringing any. And if we think about listing our subsets out, what does none apply to? Well, it applies to the empty set. So let's not include the empty set as an option, because that's not an option. She's not going to not bring any books. So let's think about what would happen if she brought some of the books. If we list all the subsets, those should all be included. So all the some possibilities are included if we list out all the subsets. And then what about all? She might bring all. And I'm saying this because it explicitly says in the problem that she might bring some or all. So because it said that, we can be open to some of them. We can be open to all of them. And so some and all, that would be included in doing the total number of subsets. So what I'm going to do is I'm going to write down the subset formula. So the number of subsets is equal to 2 to the nth power. And so I'm gonna do that in my calculator with n being 13. So 2 to the 13th power, so 2 to the 13th power, okay, gives us 8,192 different possibilities. But we said at the very top here that it's not possible for her to bring none. So we don't want to include the empty set. And when we use this formula, when we list out the subsets, that always includes the empty set. In fact, you can even look at the example that I did at the beginning of the video. When I listed out the subsets for 1, 2, I included the empty set. And same with proper subsets. When I listed out the subsets for a set ABC, I included the empty set. So because of that, I'm going to take off 1. So I'm going to subtract 1 here to not count, so don't count the empty set. All of the other subsets that would be listed when we factor, when we do this formula and we think about the 8,192 possibilities, all the rest are okay. We just don't want to count the empty set. So my final answer is going to be 8,194 different possibilities. So it's a good thing we have this formula, because that would be near impossible to list those all out without it.